Hi guys, today we're going to be talking about prime numbers and using the prime factorization method in some word problems. So this word problem says, 3 motorcyclists ride around a circular course starting at the same place and same time. The first passes the starting point every 12 minutes, the second every 18 minutes, and the third every 16 minutes. After how many minutes will all 3 pass the starting point again at the same time? So to start this problem, we have to decide if we're going to use the least common multiple method or the greatest common divisor method. For this one, we're going to be using the least common multiple method because we want to see the least time that they will all pass the same point. So to do this, we are going to use the prime factorization method, and to start out that, we're going to pick our first number. So 12 is our first number, and what we're going to do is make some tree branches come off of that. And then we're going to see what 2 numbers can be multiplied together to get 12, or what are 2 factors of 12, in other words. So for this one, we can do 2 times 6, because 2 times 6 is 12. 2 is a prime number, so we can no longer break this one down. 6 isn't a prime number, so we're going to break that one down even more. 6 can be broken down into 2 times 3. 2 and 2 are prime, as well as 3, so this is done. So the prime factorization for 12 is going to be 2 squared, because there's 2 2's, times 3. Let's move on to 18. Let's draw our tree branches. 18 can be factored by 2 and 9, because 2 times 9 is 18. 2 is prime, so let's factor 9. 9 can be broken down into 3 times 3. As we saw before, 2 is prime as well as 3, so this 18 is broken down as far as it can go. So the prime factorization for this will be 2, because there's only one 2, times 3 squared, because there's 2 3's. Lastly, let's look at number 16. 16 can be factored by 2 times 8. 2 times 8 is 16. 2 is a prime number, and 8 is not, so we're going to break down 8 once again. 8 can be broken down into 4 times 2. And 4 can be broken down once again into 2 times 2. So the prime factorization for 16 is going to be 2, because this is our prime number 2, and we have 2 1, 2, 3, 4 times, so 2 to the 4th. Our book describes prime factorization of the least common multiple as the product of each prime that is a factor of any of the given numbers, raised to the greatest power of that prime that occurs in any of the individual prime factorizations. So in other words, we're going to see out of these prime factorizations right here, what one occurs the most, what the highest power is that we can use out of all of these. So for the least common multiple factorization, let's look at 2. 2 is in all of these, and the highest power of 2 out of all these prime factorizations is 2 to the 4th. So we're going to use 2 to the 4th. Now, let's look at these two. These two have 3. 2 times 3, 2 times 3. The highest power of 3 is 3 squared. So we're going to use 3 squared. Now there's no numbers left, so then we're done with our prime factorization of least common multiple. However, 2 to the 4th times 3 squared can be broken down even more. 2 to the 4th is 16, times 3 squared is 9, which means that equals 144. So after 144 minutes, all 3 will pass the starting point again at the same time. And there's your answer for number 1. Let's try one more problem. This problem says, Anna has made 42 chocolate chip cookies and 54 sugar cookies. She wants to put them in bags for her friends with the same number of cookies in each bag, the same kind of cookies in each bag, and no cookies left over. What is the greatest number of cookies she can put in each bag? So, unlike the other one, this one is looking for the greatest number, or the greatest common divisor. So, we're going to use the prime factorization method as we did in the last one. So we're going to take 42, because we're looking for 42. She has 42 chocolate chip cookies, and she has 54. So let's break these two down. 42 can be broken down into the factors of 2 times 21. 2 is prime, as we know, because it can only be multiplied by itself. It can't be multiplied by any other numbers. 21 can be broken down into 7 times 3. 7 is prime, 3 is prime, and 2 is prime. So the prime factorization of 42 is going to be 2, because we have 1, 2, times 3, because we have 1, 3, and 7, because we have 1, 7. Let's look at 54. 54 can be broken down into 2 times 27. 2 is prime, 27 isn't, so we're going to break that down again. 27 can be broken down into 3 times 9. 3 is prime, so we're going to leave that one. 9 can be broken down into 3 times 3. Prime factorization of 54 would be 2 times 3 to the 1, 2, 3 third power. So, given this information, we're going to try to find the greatest number of cookies that Anna can make for her friends. So, the greatest common divisor is the product of the common prime factors, each raised to the lowest power of that prime that occurs in any of the prime factorizations. So in other words, we're going to look at these two prime factorizations and see which numbers out of these have the lowest power in both of them. So 2, let's look at 2. 2 is in both the factorizations of 42 and 54. So we're going to write 2 down. And 3 is also in the prime factorizations of both of these. So we're going to use 2 and 3. Next, we're going to look at the lowest power out of these two prime factorizations of 2 is 2 technically to the first. So we're going to leave 2 to the first times lowest factorization of 3. This one is just 3 to the first power. This is 3 to the third power. So obviously 1 is lower than 3, so we're going to use just 3 to the first power. Factor those out, so 2 times 3, which equals 6. So the greatest common divisor of this problem is 6, or in other words, 6 cookies can be fit into each bag for Anna's friends. Hopefully this helps.